What you'll notice with all the probability types is evaluating the expected value and the variance is very similar, but the actual calculation itself just slightly changes depending on what form your probability is given in. So if we're trying to find the expected value or the mean of a continuous probability function or a probability density function, how we'd calculate that is we'd evaluate the integral from -infinity to infinity, so wherever the function is defined pretty much, because the zero region will make no difference to this calc. And then we just evaluate x multiplied by p of x with respect to x. And that's how we evaluate it. It's very similar to a discrete probability table where you would multiply x with your individual probabilities and add them up. But instead of adding the numbers, we're just taking the integral of the function instead. So you can see the calculation is very similar in its methodology and its spirit, but the only difference is just the means that we're getting our probabilities from. In this case, it's an integral. With the other ones, we're just adding them together for discrete events. Now, variance is very similar. We're evaluating e of x squared minus e of x all squared on the outside, and you can kind of guess where we'd go from here. This would be the integral of x squared p of x with respect to x from -infinity to +infinity, minusing the mean squared, which is that calculation up there, all squared. So be from -infinity to infinity of x multiplied by p of x with respect to x, and that's all squared. We're not really going to walk through an example because you can imagine this is fairly straightforward in terms of applying the formula, but sometimes the algebra can be quite complex, especially when you're multiplying a function by x squared. So I'd recommend just doing practice with different types of functions, with trigonometric functions, with polynomials, with exponential functions, and just make sure that you get familiar with the calculation before you jump into a SAC or an exam.